Welcome to another data science deep dive on our technical track. In the following session, Liang Wu, machine learning data scientist at AirBnb, talks about how choosing the correct optimization metric is key to the success of a search engine. He investigates factors needed to be considered when they are in search for good metric, and he walks through an example of designing an optimization metric for a particular business, including how it is selected, mathematically defined, and optimized with a machine learning framework. Enjoy.
So I'm going to talk about product search in e-commerce, what to optimize. And I'm not going to talk about like a very complicated algorithms like deep neural networks, like even like SVM. And today we are like building more and more like complex models, and we try to train our computers to like generate the ideal results for us. But actually, the key to success is what do we feed into the models? Like what labels do we use, like to let the algorithm to learn? And I'm gonna like talk about the label part of the search engine in e-commerce. And a little background about me. I'm currently a machine learning data scientist in Airbnb, and I'm working on Airbnb experiences. It's like a startup inside Airbnb. We are trying to recommend local tours and unique activities, like for people who travel. And those activities are hosted by the locals and recommended by locals. And before that, I used to work in Etsy. And the technical part of my presentation is publish a paper in together with Etsy, and it's published in 2018. So we are gonna focus on the problem of ranking. So this is like a history of ranking, a brief, very, very extremely brief history. And it started with web search. So you input a query and you get a list of document results, web document results. And now there are more and more kinds of e-commerce search engines. And the second picture is from Etsy, the third one is from Spotify, and the last one is from Airbnb. So basically you still input a query, but the output is like music or items or homes to stay. And here are the examples, like for e-commerce search, the input is a search query, and the output is the candidate products. So it's if we talk about the algorithm, it's very similar to traditional web search. So because the output is a ranked list of related documents. So it's basically called a ranking problem, or we sometimes call it a learning to rank problem, like Tor. So it's a supervised learning task. So given data and labels, and the model tries to like learn something, learn to like fit the labels. And it's supervised learning, so it's different from classification. So classification is like a binary, the label is binary, true or false. And it's also a little different from regression, where you learn the probability of a label, like a probability of being true is like 60%. And for ranking, what we try to learn is the perfect ranked list. And there are three kinds of objective functions for learning to rank problems: point-wise, pair-wise, and list-wise. So for point-wise, so imagine we are gonna rank these 4 items, and we know the ground truth, and the item 1 is the best with a score of 10, and the last one, item 4, is the worst in the list. The score is a 6.3. So we try to predict the scores of them, so that the ranking list will be the perfect ranking list from item 1 to item 4. So if we use a pointwise objective function, it means we try to learn each item of them individually. So let's say here are the predictions, and we make some mistakes. For item 2, the score is 8, we predict it as 7, and this score is 7, we predict it as 8. So in the next round, we are gonna try to optimize our model so that the prediction for the second item is a little larger, 7.1. And the prediction of the third item is gonna be a little smaller, 7.9. So eventually we will have the perfect ranking. But this style is like very ineffective. So imagine we have like 100 iterations of training a model, and maybe 90% of the iterations are like this. So we modify the model score a little bit, but the rank list doesn't change. So it's still the original 4 items, like the original ranking results. So the second kind of objective function is pairwise. So what we do is we directly learn the preference like between the pairwise comparison of 2 listings. So if item 2, the prediction of item 2 is larger than prediction of item 3, then it's true, otherwise it's false. So then every iteration, like the rank list will be changed a little bit, like towards the optimal ranking results. And it also has a huge problem. Imagine if we have a lot of ranking results, and we also, like we give labels to the model, and model is trying to learn each pair of them. So the model is gonna, like first focus on the top 2, and then like 2 and 3, and then second page. But do users really examine the results on the second page? So do you know where is the best place to hide a dead body? It's the second page of Google search results. So users are never gonna examine the results on the second page, but the model is gonna spend a lot of time on it. So it doesn't make sense. So the problem is the algorithm will overlook the top results. So what we do is the third kind of objective function is list-wise. So what we do is we try to utilize the list information. For example, the top pair, the top 2 items, this pair is going to have a higher weight than the rest of the pairs, like than the pairs on the second page. Okay, that's the technical part. And here comes the what I really want to talk about. So how do we define labels? Like we talk about all these like pointwise, pairwise, listwise, but these are the like styles of the objective function. But how do we generate these scores? How do we get the labels? It's relatively easy for web search if you work in Google or like Microsoft Bings. So because the labels are generated based on manual annotation, so they basically hire the search experts to like manually score. Like this one is score of has a score of 4, and the next one has a score of 3. And then it's like an ideal world. You just let the model try to learn the optimal ranking. But in e-commerce, we don't have labels. We don't have like e-commerce search experts like sitting there just label the data all day for us. So usually what we do is we focus on the user feedback signals. So this is also a snapshot from Etsy. So when you try to buy something like fossilized something, like then you will see the results, you will click on some of them, and then you will purchase on some of them. And then the model will log all these behaviors, and we will try to generate labels based on these feedback signals, clicks and purchases, and also the prices. So here are some possible labels. I have like a scene in the area. So the most straightforward one is called click-through rate. So it's the number of clicks divided by the number of impressions. Like it can be used by web search. Like also like search ads, they are using the click-through rate. And for e-commerce website, we may also use conversion rate. So it's the number of purchases divided by the number of impressions. So we try to optimize the number of purchases. And it makes sense for e-commerce, right? And the third one is a little weird. So it's the number of purchases divided by the number of clicks. So we still try to optimize like the maximum purchases, but we try to punish the number of clicks. So it makes sense for navigational search. It means like if you have a clear goal, you know what you want to purchase. So sometimes we want to punish the number of clicks to lead you to the results you want. And in e-commerce, we also have another signal. It's called price. And sometimes we may time the price with the purchases divided by impressions. So it means we want to optimize the sales of more expensive listings. Sounds a little weird, right? I will explain more about this later in the next slide. And so similarly, we may also use price as a weight to weight the number of purchases divided by the number of clicks. So we try to punish the purchase of cheap listings, and our goal is to drive revenue. So basically, we have 3 signals to use here. The first one is click. So clicks are mostly used for informational search, like web search, and the clicks shows the relevance, the relevance between the user intents to the to the content of the information. But it may be very poisonous for navigational search and the transactional search. So imagine, let's say some supermarket like Walmart or Target is an e-commerce website. And today I want to buy some battery and drive there. And in order to optimize, to maximize the click-through rate, so basically click-through rate means page views. So in order to maximize my page views, what the store will do is hide the battery in the frozen food and without a notice. So then I will need to examine every shelf from grocery to food, baking, and diapers, and paper towels, and pet food. Then I will find, oh, battery is in the frozen food area. So instead of checking only one shelf in the entrance, I check every shelf in the Walmart store. So the data scientist can then report to his manager, after A/B testing. So the customer likes our algorithm so much. So instead of only spend 1 minute and checking one shelf, I started checking 100 shelves. So it's optimizing the number of clicks. And the problem is the users won't be happy, won't be satisfied, because the shopping experience becomes like a scavenger hunt. Basically, if you throw everything just randomly in the store, users will need to click everything in your website until they purchase something. So they won't do it again. They won't visit you again. Then another one is conversion. So it's the most a strong signal in e-commerce websites. But one problem is where it is very sparse to optimize, especially when your website doesn't have a lot of traffic. And it's also poisonous at some time if your website has a lot of cheap listings. So I have another example. Imagine the Best Buy is also an online store, and I try to buy I try to buy an iPhone. I go straight forward to the iPhone area, and then I will see piles of all the iPhone covers, AirPods, bags for iPhones. After I walk 1 mile, I saw the iPhone I want to buy. Then I will ask the shop owner, why do you put the iPhone on the very end of your store? Because they will say, because we try to optimize the number of conversions. People don't buy iPhones that frequently. If I drive to a store, I check an iPhone, I may not buy it. I may check the next store. But if I drive to Best Buy to only buy an iPhone cover, I may buy it immediately. So the data scientist who launched this algorithm is going to be super happy. Wow, our number of purchases, conversion rate, increased 100%. We basically abandon all the iPhone buyers and we try to welcome all the cheap listing buyers. And after 1 year, the data scientist will be promoted very high, but Best Buy will become a Dollar Tree, some 99-cent store. So conversion rate is easily to be dominated by cheap listings. And the last one is purchase price. So basically, we try to higher weight the purchase of iPhones based on the price. One iPhone purchase maybe 500 more important than iPhone cover purchase. So what to optimize? It's a big question. I think it really depends on what kind of business you have. And this is an example of Etsy. So Etsy is a very good website because I already left Etsy. But I still visit Etsy frequently when I want to purchase some gifts, for my family, for my colleagues, and it's all the handcrafted, really nice gifts. But the problem is It's not like Amazon. You go to Amazon very frequently. Like you know what you want to buy. But for Etsy, it's like I'm gonna purchase something for my PhD advisor next month. And since 2 months ago, I started browsing Etsy. I click a lot. I think I will make the purchase probably next week or 2 weeks later because I'm gonna visit my university like next month. So it's like the user has a lot of clicks, but it's not the noisy clicks. When I purchase a battery and you hide the battery in the frozen food. It's all the useful clicks, but I will also make a purchase. The purchase is also important. So what we try to do in Etsy is we try to jointly optimize the click-through rate and the purchase rate. So what we do is we propose this new objective function, and the first part is probability of click, and the second part is probability of purchase. So the technical content and my presentation is available in YouTube. I provide a link over there. And so this is a proposed solution. I think the interesting part is we separated the shopping experience, shopping journey into 2 stages. The first stage, user tries to choose a product to click. So this is like a learning to rank problem. So basically you try to compare which listings is the best for your intent. And in the second stage, the users will browse the product description page and decide whether they will purchase it. So it will become a purchase classification problem, like a binary classification. And we propose this method to optimize it. And the interesting part for this, for this one is this is the ultimate objective function, and it's GMV. And instead of using price as a feature, I know many websites use price as a feature. So we use price as a weight to weight each data instance. And the reason we do that is for Etsy is, for example, Etsy is a 2-sided marketplace. So price is a feature. If we use price as a feature in the ranking model, it means because the price is set by the sellers. So it means we are giving our sellers a way to manipulate the ranking results, based on one feature. If price is for example, if price is a very positive feature, then the seller may just set this ring. The price is it should be 100. Just make it 100 million. They will show up in every search result. So that's why we try to put the price as a weight instead of as a feature. And then we run experiments with Etsy data sets. And we did 2 experiments. One is based on the ranking metric. So to measure, the metric is called NDCG. So we try to compare different algorithms, which one ranked the best. And in the second experiment, we try to also measure the revenue of each method. So what we do is we run a simulation test. And we ask a different algorithm to rank the results and see which algorithm is gonna bring us the most revenue. So we compare with different kinds of algorithms, click optimization models, purchase optimization models, and the last one, the method letter rate is the proposed model. So this is experimental results on the NDCG. So it basically measures how well the model ranks the results. And our methods win the purchase NDCG and the revenue NDCG, but we lost the click NDCG. So still for the click for the click ranking problem, still the best results is achieved by the click optimization models. But this is the revenue at K. So it means K means if we run the simulation test, if we put a true positive listing, the listing that the user has purchased, in the top K position, and the user is gonna purchase again. So K is how far away the user is gonna examine your search results. And we also the proposed method, the last method, wins all the tasks except the revenue at 1. So for example, if a user is gonna examine the top 10 results, revenue at 10, so the proposed method is gonna make $6 54 cents for each search section, compared with other methods, like a little more money. And I also want to talk about something more, that was the end of the technical part. So beyond clicks and conversions, actually there are some other things we need to consider. Like for example, for clicks, it's most useful for informational search. So we try to know some information, like when you use web search. So that's why click-through rate and also dwell time is an important metric. And I personally think click is a immediate a feedback signal you will see. If you change something, the click-through rate is gonna change very fast. So if you use clicks to if you try to optimize clicks, it means you are optimizing the immediate term growth. And for the conversion, because conversion is kind of difficult to optimize because the a purchase signal is usually very sparse in the data set, and it also may unfairly dominated by cheap listings. But it really tries to measure growth of a website. If users are more and more purchasing something, that's a very good signal. And for the price, what we do in Etsy, so it's if we use price in the objective function, it means we are trying to highlight expensive yet rare transactions. So we are ultimately optimizing the profitability. So it means the conversion rate may be lower, and the purchases may be fewer, but the total profit is going to increase. So it depends on what kind of business. And I really want to talk about the quality. So the term of quality is not usually mentioned in the web search, product search area. And I think this is actually the most useful for startup companies. I just described, I come from Airbnb. I work on Airbnb experiences. I think many people don't know what our Airbnb experience is. So at this time, the search engine of Airbnb experiences have two responsibilities. The first one is the first responsibility is a conventional responsibility. We try to enable users to easily find what they are looking for. But there is also another role of the search engine is to educate our users about what kind of business we are. So the users, I mentioned Airbnb experiences to you. You may search it an iPhone offline, but you don't know what it is. So it basically means you don't have an intent and there's no relevance. So at this time, we should also enhance the quality. It means we don't really care about the click-through rate. We don't really care about the conversion rate. It's not important whether you visit our website and then book something. But the important thing is, what matters is, you visit our website, you didn't buy anything, but you have a very good impression. Wow, this is so cool. It's not TripAdvisor. It's not Amazon for local tours, but it's Airbnb experiences. It's category-defining startup. So that's why quality is also very important. So enhance the quality, we may add quality as a feature or add quality as a weight in the objective function. And that's it. Let's stay connected. And here are my personal websites.
Thanks, Liang. So there are a couple questions. The first question I want to ask, I think you just answered, but I'm going to ask it anyway because someone emojied it up. And I said that if someone emojied it up, I would ask it first, or I sort of implied that as a feature. So when calculating revenue, do you consider the quality of the quantity of the product? Because I forget everything I said. Do you consider the quantity of the product? If so, how do you predict it?
Yeah, we don't explicitly use quantity in the objective function, weighted some objective by the number of purchases, but but there's gonna be more purchases of such items in the data set. For example, on Etsy, I think the most of one of the most frequently purchased stuff is the stickers. It's really cheap. but users are gonna buy a bunch of them, and we did consider them like implicitly.
Okay, and as another question from Alex, why did you need click and purchase probability separately? Can you model the final revenue per product?
Yeah, so I think one very conventional practice in e-commerce search is we just add everything together, clicks. Like a purchase is for example, like 1,000 a purchase is 1,000 clicks. We just merge everything together, and then we will have a weighted object function. I think it works. I think this practice, I first seen it in search advertising. So basically, you have click-through rate, you have conversion rate, and the search advertising, Google and Microsoft try to optimize both of them because they are going to make money if you click through ads on the on their website. But I think in e-commerce, sometimes the purchase is not really 1,000 clicks. They are just different. We have seen many experiments the clicks are up, but the purchases are down. Also, many experiments, purchases are up, but clicks are down. So at this time, they're just not equal. They're on the opposite side.
Great, thanks. From Rui, question for Liang. If we are using price as weight, what are the pre-processing needed to have a canonical product price?
Yeah, brilliant question. So if you directly use weight or price as a feature, as a weight, actually it's problematic. There will be problems because the price distribution is parallel distribution. So if you directly use price, it means the heavy head, the most expensive products are gonna dominate the results. So what we do is we calibrate out the price in a certain distribution and weigh them. Brilliant question.
Thanks. And also from someone in that same area, from Nan, how do you estimate probability of purchase if the product is unique or single quantity?
Yeah, it's also a brilliant question. Because in Etsy, it's a handmade crafts and vintages. So every listing is very unique. So what we do is we may instead of model each listing, we may model the product category and model the based on the shop owner and the model category. We may not directly focus on each listing, very small granularity.
Great, thanks. And one last question. For labeling feedback signals, what is the number of impressions? For example, the number of clicks divided by divided by the number of impressions.
That should be a very small number. I don't have it on top of my
Okay.
mind.
Well, thanks. So again, everyone, thank you to Liang.
That was Liang Wu, machine learning data scientist at AirBnB, with his presentation on what factors needed to be considered when in search for a good optimization metric, and shared an example of designing an optimization metric for a particular business. If you'd like to watch more videos like this, you can subscribe to the DSS Insider program, where you can see our complete on-demand video repository from a wide range of topics. Subscribe now, following the link in our video description below, and also follow the channel.